Hello, incredibly awesome student. So we are going to complete part 3 of the video series going over the reassessment day review. In part 1, we covered standards 6C and 7B. In part 2, we covered 7C and 8A. This is going to be part 3, where I go over the remaining standards. So let's start off with standard 9A. Before we start standard 9A and also F9, there are some important things to remember. There are closed circles or closed dots. That's if it's greater than or equal to or less than or equal to. And then there are open dots if it's greater than or less than. So that's very important to decide whether our answers include the solutions or do not include the solutions. So this is standard 9A, solving and graphing one variable inequalities. Number 1, consider the inequality 2x minus 5 is greater than or equal to 5. Solve the inequality, graph the numbers on a number line, graph the solutions on a number line. So for problem number 1, we're going to add 5. That gives us 2x is greater than or equal to 10. After that, we're going to divide by 2. Dividing by 2 gives us x is greater than or equal to 5. So I'm going to go ahead and put this on a number line. Here's the number 5 on a number line. It's going to be a closed dot, and it's going to be greater. Remember, you can always substitute numbers into your equation to decide if it's greater than or less than. For example, is 1,000 a solution? If you plugged in the number or substituted the number 1,000 into this equation, would 1,000 be a solution? Absolutely. 1995 is way greater than 5. So we're going to definitely include those numbers to the right of 5. So letter A, we graph it. Letter B, is the value 3.5 a solution? We can say no. 3.5 is not greater than or equal to 5. Also, if we substitute 3.5 into our original inequality, it would give us a false statement. So the answer is no. Problem number 2. Solve the inequality and graph it on a number line. For this one, I'm going to distribute the negative 3. That gives me negative 6x. Now I'm going to carefully distribute the negative 3 into this part as well. Negative 3 times negative 1 is positive 3. Solving, I will get negative 6x minus 3 is greater than 21. I combine 3 minus 3. 3 minus 6. 3 minus 6 is negative 3. I will then add 3. That gives me negative 6x is greater than 24. 21 plus 3 is 24. And now I will divide by negative 6. Now you can use the trick that we remember where if we ever divide or multiply by a negative number, we must flip the sign. When we multiply or divide by a negative number, you must flip the sign. So that's going to be x is less than negative 4. So notice, instead of it being a greater than symbol, I now make it a less than symbol because I divided by a negative number. Now, of course, you could just plot your boundary point, which is negative 4. It's an open circle, by the way, right? Since it's less than. You could plot your boundary point and test a number. And I already tested 0. 0 was not a solution. So therefore my answers are everything less than -4. Our next question says, is the value of 8 a solution? No, it is not. For one, 8 is not less than 4. Second, if you substitute the number 8 into your inequality, you will get a false statement as well. So if you plug in or substitute the number 8 into your equation, you will get a false statement. Number 3. Solve the absolute value inequality. Graph your solutions on a number line. So since it's absolute value, I know there's very likely going to be two solutions. So for number 3, I'm going to split my absolute value into 2 possible solutions, or 2 possible boundary points. We get x plus 2 is greater than or equal to 1. And for this one, I'm going to do the opposite. X plus 2 is less than or equal to -1. Now notice, not only did I switch the symbol, I also switched the sign of the number. So not only did the number switch, but the symbol switched from greater than or equal to less than or equal to. Now solving, I will get my first solution of x is greater than or equal to -1. And solving the second solution or boundary point, I will get x is less than or equal to -3. So plotting those boundary points, I will get closed dots on -1 and another closed dot on -3. The first one says it's got to be greater than -1, greater than or equal to -1. The second solution set says that it's got to be less than or equal to -3. So that is my answer. Again, if you need to substitute some numbers in, I will show an example. If you substitute the number 0 in, would it give you a true statement? 0 plus 2, again, this is just the original inequality. 0 plus 2, is that greater than or equal to 1? Yes. So we know that 0 is a solution. You can also substitute some numbers in this region as well, and you'll get that the answers here are true, the answers here are true, and these are not going to be solutions, the numbers that are in between -3 and -1. Okay, number 4. Number 4, there are 2 ways to solve this. I will show it in both ways. The first way is the way that most students, the majority of students solve it this way. Distribution. If you distribute, that's fine. You have to remember to distribute the 4 into both numbers though, right? So that gives us 4x minus 20 is less than 16. The second way to solve this is my preferred method for this type of problem is I know that this is a multiplication problem. 4 times x minus 5 is less than 16. Well, multiplication, what's the opposite of multiplication, right? Division. If I divide by 4, why would I divide by 4? I will only divide by 4 if it goes into this number. 16 and 4, I know that 4 goes into 16, so I will divide by 4. So before I finish this one, I do want to show you this one just so we get the same answer. Adding 20 gives us 4x is less than 36. Divide by 4, that gives us x is less than 9. Alternatively, what's this? We get x minus 5 is less than 4. 16 divided by 4 is 4. Add 5 You see how quick this one is? If we just do division and then addition, we'll get 4x is less than 9. Which one's quicker? Distributing or dividing? You get to decide what you'd like to do. So graphing the solutions, I will get an open circle since it's less than. Remember, 9 is not a solution, but everything that is less than 9 is a solution. Okay, so that covers standard 9A. We're going to move on to standard F6 now. F6. This one is called solving for a variable. So solving for a variable is a standard F6. We just need to make sure that we solve for a variable by getting that variable by itself. So if it says solve for x, I must isolate x. I'm gonna write that down here. Isolate x. I want to get x by itself, at least for this problem. So to do that, I'm gonna go ahead and add 4c. That gives us me x over 4 is equal to d plus 4c. And how do I get rid of that 4? The opposite of division is multiplication. So I'm going to multiply both sides by 4, giving me my answer of x equals 4 times d plus 4c. Now that is how I'd probably write my answer. You could also write your answer as 4d plus 16c if you distributed. But that is going to be a great way to write the answer, at least for standard F6, problem number 1. Okay, next up is problem number 2, solve for y. That means I need to isolate y. To isolate y, I get r equals x, y, z. X times y times z. What is the opposite of multiplication? Division. So I'm going to divide by x, and I'm also going to divide by z. Dividing by x and z gets rid of those variables, leaving me with y equals r over x z. That is my answer. Next up is number 3, solve for b. So solving for b, I need to get b by itself. So I'm going to subtract the ax. That gives me by equals 2 plus c minus ax. And I'll need to get rid of the y. So I'm going to, because I do need to get b by itself, so I'll divide by y. Dividing by y gets rid of the y, leaving me with my final answer of b equals 2 plus c minus ax, all divided by y. Now number 4, solve for m. So I need to get m by itself. I will move the 9n to the other side by subtraction. That leaves us 18m is equal to 5 minus 9n. You could rewrite this if you wanted to. You could write this as negative 9n plus 5. It's the same thing. But either answer is okay. So finally, let's get m by itself by dividing by 18. And that gives me my final answer of m equals 5 minus 9n, all divided by 18. Now this is a very appropriate answer. You could also write this as 5 over 18 minus n over 2. If you did simplify that, that is also totally fine. But this answer right here is very, very good. Now standard F7, solving for missing angles. So for the first one, we have vertical angles. Vertical angles are congruent. They are equal to each other. So I will set x plus 16 equal to 4x minus 5. For the second problem set, these are complementary. So they will add to 90 degrees. So we have 35 plus 4x plus 7 equals 90 degrees. For the third and fourth ones, we do have supplementary angles. Supplementary angles are linear pairs, or they add up to a straight line. How many degrees are in a straight line? We know it's 180 degrees. So this will be 2x plus 3 plus x minus 6 is 180. And for the final one, we also have that they add up to a straight line. So x minus 20 plus x plus 40 adds up to 180. At this point, I'm going to pause the video and you are going to find the solutions for x. Once we have the equations, we can solve for x. So at this point, I'm going to pause and you can check your work. See if we get the same answer for x. All right, so for problem number, or F7 letter A, we get x equals 7. For letter B, we get x equals 12. Solving letter C, we get x equals 61. And solving letter D, we get x equals 80. Let's now move on to standard F9. F9 wraps up the problem sets here. So F9 is notation and equations of inequalities. So for the first one, we should get an answer of x is less than -1, because this is an open circle. For problem number 2, we're supposed to graph the inequality of a number line. This is going to be x is greater than or equal to -4. So I will have a closed dot. Greater than will be pointing to the right. For number 3, A and B, we have, this is going to be a between question. So I'm going to have x is less than or equal to 4, closed dot. And we also have x is greater than -2. This one's open. So this will be my answer. It could also be written as x is greater than -2 and x is less than or equal to 4. But you can also write it combined like this. Okay, number 3B. This is going to be an OR question. X is less than or equal to -2 or greater than 2. And for number 4, we have true or false statements. So 1 is greater than -61. This is true. -200 is not greater than -199. 12 is equal to 12. There's an equal sign. And finally, 9 is not less than 9. So this wraps up standards 9A, F6, F7, and F9.